Hello Year 12, we're back and with the second of these videos for logarithms, and we are talking about the logarithmic function now, right? We're going to use that definite article, the logarithmic function, because this is the really important one. So that's where we have a base e. Y equals the log base e of x. We call it natural logarithms, sometimes they're Napier logarithms. And we need to know a few of these properties about it, right? We talked about some of these previously, and you can read those things there if you want to slow things down and check that out. Remember that the domain has a limitation on it that x has to be greater than or equal to 0. Sorry, can't be equal to 0. X is greater than 0. Range is all values of y, or all real y. There is, those limits there as it approaches different things. Helpful enough to know. Rightio. Now, for the time being, we're going to learn here that the derivative of this function is 1 over x. There we go, very straightforward. Right. That's why we use this natural logarithm all the time, this base e, because of the differential there, that 1 over x is. Works out so neatly when we do so many other things in a very similar way as differentiating e to the power of x. We keep in that e to the power of x, and we get neat results with this too. So we have this function here, y equals the log of x. You'll notice the textbook tends to use log base e, right? That script. I tend to use ln, right, for natural logs. 1, it's what appears on your calculator. 2, I'm a bit lazy and it's faster. But be aware that it could be either way, right? Personally, I think that this is, by and large, less ambiguous, right? You're less likely to mix it up with the wrong base there. ln always means base e. So I'm going to find the equation of the tangent. We know that. We know the x-intercept is. We know the x-intercept is at 1, but I suppose we should prove that. We're going to say let y equal 0. Therefore, the log of x equals 0. Now we sort of undo that log by raising both sides to the power of e. Right, e to the log x is x. So I get x equals e to the 0, x equals 1. Okay, so the x-intercept is when x equals 1. We know that y on dx equals 1 over x. So I'm going to say, let's say, function prime. We're going to switch to this function notation of 1 equals 1 over 1 equals 1. Now we know that y minus y1, well, that's going to be y minus 0 equals 1, oops, y minus 0 equals 1 into x minus 1. Therefore, y equals x minus 1. That's the equation of the tangent at the x-intercept. Y equals x minus 1. Fantastic. Rightio, quick video there. There's not a lot to it. It's a little bit of familiarity with that exponential function.